Not loud. Oh, that's better. Testing. That's pretty loud. You may remember me from such Python meetups as Java, Why Do They Smell Funny? And a guided tour of Guido van Rossum's toes. But when Grace asked me to give this talk tonight, I demurred. I said, that seems more like a Shelbyville idea. Here's a little bit about me. The key thing is that one there, open to new opportunities. So davidschachter@gmail.com is the email address. What we're going to talk about tonight is a project that Central Services at Zynga asked me to work on. Central Services is everything that is not specific to a particular game, code that is reusable by the other game teams, and code that teams might not have the ability to write on their own. In this particular case, we had added a player-to-player chat feature, which was optional for some games and required for other games. And the eCrime people said, hey, we need to be able to see into the user-generated content, because sometimes people use player-to-player chat to propose criminal activities. Sometimes we get requests from government agencies. You can imagine what those might be. And the eCrime people need to be able to look into this to smash evil. I realize that might lead to a little cognitive dissonance. The idea of Zynga being against evil is a little strange. This is a company named after the founder's dead dog. The word Zynga is actually the Canadian word for evil. That's not entirely true. It's actually an Inuit word meaning may the snows of 1,000 ancestors descend on your corporate health plan, but it's basically the same thing. So I went in two directions on this project. Prong number one, if you went to an East Coast school. Prong number A, if you went to school on the West Coast. If you went to Princeton, prawn, that's rather like shrimp, isn't it? The first prong was to interview the client, and that sounds obvious, but Central Services at Zynga was 100 engineers and one tech writer who was immediately laid off in the first round. Whether in management or writing code, didn't matter what your position was. If you worked in Central Services, you were an engineer. So they had no concept whatsoever, and this is not a joke, of marketing, sales, customer support, education, training. None of that. So when I said I'm going to go talk to the client, people were going, you're going to do what to the whom? The other prong was to read the code, find out how this chat system called Conversations works. And these two things worked together. The more I knew about the code, the smarter my questions could be, and the more I interviewed the client, the more I knew what to look for in the code. What I got from the client were these key takeaways. I identified their needs, their wants, and also the nice-to-haves. I always like to give the client one or two extra things that they didn't pay for. I'm not going to get any revenue from it, and I'll have to maintain it forever, but it makes them feel like I care about their pissant little problem. And I also wanted to find out why Central Services had such a bad reputation. The key takeaways after all these interviews, the first one up here, they came back to over and over again. They said, look, we have to be able to stand up in court and affirm that the testimony we're about to give is the truth, which means the data has to be defensible. And as you'll see in a moment, that was a big deal. The data has to be deleted after exactly 60 days for legal reasons. The next two items were really interesting. They're only going to be running queries against the system maybe 2 or 3 times a day. And they don't mind if it takes a minute to get a response. So that certainly made life a lot easier in the design of the server. And the last of the key takeaways was that once we're done building it, once I'm done with the system, they're not going to let me on it anymore. It's going to be closed off for security reasons. Oops, that was exciting. The code was also interesting. Only 4% of the code, and this is all PHP we're talking about. You can see why I left. Only 4% of the code was the actual conversations logic, the chat logic. 96% of it was infrastructure. The guy who wrote it had graduated recently from Princeton. Fine school, or so I'm told. Make an even better pig farm. It's okay, I'm not bitter. The rest of the code was infrastructural code to provide layers, which were unneeded, to provide separation of concerns, inversion of concerns, dependency injection, testability. And if you notice the last line on there, over half of the code was just test code. How much of that 96% did the people playing Zynga games care about? None whatsoever. Gave them no benefit. So 24/25 of the code this guy wrote was not a benefit to the people paying our bills. Made him feel good, made his computer science professor feel great. Had nothing to do with delivering a project, just infrastructure. The deployment for the system used Membase for the database layer. Membase is memcache plus persistence. That's not an analogy, that's what it actually is. And like memcache, it has no accounting, no authentication, no audit trails. Anybody inside the corporate firewall can modify any data in Membase. Hence the concern that the eCrime people had about making sure that the data was untouchable. So I had to build some system that would be write-only and not updatable, not modifiable. The business logic tier in front of these Membases, supporting conversations, had 800 servers at the time. Supporting not just conversations, but another roughly 20 plugins along with conversations plugin. That's kind of interesting, having all of these plugins operating inside the same Apache process. Because what do you think happens if any one of those plugins has a bug, a fatal bug? What do you think happens to all of your central services? Yeah, it's Hiroshima and Nagasaki all over again. And this happened repeatedly. Now, what I found interesting about this was the architects at Zynga, whom I had gone to the company to work with, I wanted to work with the A team, had built this botch. As if no one had ever considered that when you put all of your stuff in one address space and any item has a problem, everything goes offline. And this was the A team. It's amazing. Anybody here who works with other people, so that rules out solo people, solo candidates, and students. If you work with other people, here's what I want you to do when you leave here. I want you to go find a pharmacy and get a box of number 2 Dixon Ticonderoga wooden pencils, not plastic, they gotta be wooden. When you get in the office tomorrow, sharpen them up to as fine a point as you can. Then find the people who are writing infrastructure code and plunge these wooden stakes into their heart until they stop moving. Customers first, customers last, customers always. When the customers are so happy with your product that you are falling over for lack of infrastructure, that's when you write infrastructural code. Not until then. And the way you write infrastructural code is you bid it out as a fixed price contract to somebody else. That will force you to be serious about what is the minimum infrastructure you need to get the job done. Otherwise, your programmers will build these giant castles in the sky because they can, because no one can evaluate the quality of their work when it's infrastructure. Focus on what the customers care about, not infrastructure. Here's the actual data flow. The player sitting at home playing some social game with Flash sends a message. The message hits a load balancer at Zynga. The load balancer forwards to the game server. Game server creates an HTTP request because central service is all HTTP. Sends that to the load balancer. Load balancer forwards it to a Java server, which is doing what's called prioritization, batching, and routing. Another piece of architectural garbage that was badly designed, poorly implemented, and crashed frequently, causing all the games to go offline. If it doesn't crash, it will create a brand new HTTP message, send that to the load balancer, which will be forwarded to the Apache servers, those 800 servers I just talked about. That server will figure out which of the 20 plugins needs to get the message and a bunch of other work. That's 1,000 lines of PHP, and eventually it will get down to the conversations plugin to run the code. The throughput of the system was roughly 40 messages per core per second. You can see why we had tens of thousands of servers. Infrastructure. After all this, I figured out I only needed to add one line of code. You can see it up there on the screen. To the function that creates a new message, I added a PHP call to my new function, send message to eCrime. And just to give you one last example of how bad this garbage was, here's the code that I started with to send a message to Scribe. Scribe is the transport layer, comes out of Facebook. I think it's an Apache project now. The code that I inherited did all of this work to send a packet through Scribe, including bit twiddling in PHP, bit twiddling the packet. I replaced it with override a couple of data fields in a pre-built packet, send it through a pre-built socket, we're done. The original code, 6 functions, 300 lines. The replacement code, 1 function, 20 lines. Here's the picture of the system I built. At the top left, you see those servers I was talking about, the 800 servers. And by the way, they did eventually figure out that that was a botch and split it up into an individual server cluster for each of the 20 central services. But they never figured out that the routing layer in front was also crashing. I proposed splitting up the routing layer the same way, and I was told that the virtualization layer that they were using for flexibility didn't allow them to do that. So much for flexibility. So the servers in the server cluster send the message through Scribe. Scribe dumps it into a destination directory. I have 16 processes all looking into that destination directory, contending to get exclusive access to that file. The one that wins is allowed to process the file, the rest go to sleep. Now, most of these programs, most of these 16 processes here, are sleeping most of the time. They do their work in the main loop, then they sleep for a randomized number of seconds before waking up to check again. So the odds of two processes waking up at the same time is very small, but we have to handle a potential race. So there's a simple trick for exclusive access. Why do you think I randomized the sleep times? To avoid resonance. I don't want to create an oscillator. If you are not careful, you're guaranteed to create oscillators. And if you are careful, if you try to make it oscillate, it won't. And if you try not to make it oscillate, it will. It's an old rule of electrical engineering. What I want to avoid here was the thundering herd problem. I didn't want all the processes to wake up at the same time. So the left side of this diagram is about data ingest. The right side is about query processing. We're going to come back to this diagram a few more times. Oh, one thing before I go on. That line at the top left from scribe to scribe has no more information on it besides the fact that it exists, but I'm sure there are other boxes in the network. I just don't know what they are, and no one else does either. If your data center has been around for any length of time, there are boxes in your data center that you don't know about from vendors that have gone bankrupt, installed by people who no longer work here if you're a startup or a young company like Zynga, or if you're an older company like Bank of America, they're dead. I'm glad that death is such a cheery thought for the audience tonight. The point is you have to be very careful about making any assumptions about what's going on in your network because you don't really know. There are WAN accelerators, SSL termination devices, compression devices, data intrusion devices, data exfiltration devices. You don't know what's going on in your network. And I only have a short amount of time tonight. If I had more time, I would tell you a story about how that impacted us pretty drastically at ask.com, Ask Jeeves folks. But I don't, so we'll continue. Oh, did it again. Oh, well. Clumsy fingers tonight. The manager asked for a design review. So the next morning, he and I and 6 other people were in a little room. And I said, now I know you guys are all expecting me to propose that we spin up 64 more Membase servers to keep a private copy of the data and put them behind a firewall or something to protect it. And I'm not going to propose that. I'm going to propose that we write this in Python, and that we do it on a single box. One guy immediately said, that's impossible. You cannot handle this workload on a single box. Not going to happen. He was in the first round of layoffs. Another guy said, even if you could do it on one box, it's not important because servers are free. The least of your concerns is server count. Everything else should be optimized first. Don't worry about servers. He was in the second round of layoffs. We shouldn't laugh. They're both TN1s, which is the official abbreviation for indentured servant. That's not entirely fair. Indentured servants have more rights than TN1s. I said, not only can I do it on one server, but in fact, I wrote the code last night. The power of Python compelled me to write the code last night. And it is running on this laptop right now. And here's how I did it. I built an in-memory index. Those 16 analyzer processes build an in-memory index that allows me to figure out pretty quickly where the data is. I actually have 2 indexes. The interviews I did with eCrime told me that every query would include a time box, almost always starting from now and going back 24 hours, occasionally 48, rarely beyond that. So I can use the time box to figure out what data I need to look at and get rid of everything else. We only need to keep 60 days worth of data. So using the time box, I've immediately filtered out most of it. The second thing that every query would have is either a user ID or a conversation ID. So I built these little in-memory indexes which take advantage of that. The first level index is the timestamp. I have 60 days worth of data times 86,000 seconds in a day. That's how many timestamps there are in this dictionary. So I can easily pick out only the entries which are within the time box. And the second thing I keep track of is for each file that came in via Scribe, all the user IDs in that file or all the conversation IDs in that file as a set, because I can look up things quickly in a set. Given this data structure, when a query comes in, I can immediately find out which files on disk have the messages that are responsive to the query. Then I sequentially scan those files, I in this case being the computer, or possibly me if I have tapeworm. I sequentially scan the files. That joke always works. I don't know why. It wasn't even relevant in this case. It made no sense. I sequentially scan the files, coalesce the results together because I have 16 analyzers processing these things in parallel, and send it back to the requester. Pretty simple. So here's the theory of operation. I think I already covered the first couple items on here. At midnight, an executive process sends a message to all 16 analyzers saying, get rid of all index data older than 60 days. Within less than a second, that data is gone from memory, so we've met the legal requirement for 60 days worth of data retention. And at 1 a.m., the same process sends a message to all the analyzers saying, take all of the data from the previous day's index, roll it out to disk, and delete it from memory. So we're only keeping, at most, 1 day's worth of data, plus the 1 hour from midnight to 1 a.m. Plus, when a query is being processed, we'll roll into memory day-by-day indexes to process that query. So I never have to keep all 60 days worth of indexes in memory. I only have to keep 2 days plus 1 hour, worst case. This is actually kind of stupid, doing all this rolling in and rolling out. The structure of this algorithm, if you think about it, is almost all sequential searching. So we could have increased capacity of the system to handle bigger loads if Zynga had popular games. Like that's going to happen. We could have increased capacity by adding RAM. But at Zynga, there's a CTO, Chief Technology Officer, reporting to him. It's a guy. It's always guys. How many women are in the audience tonight? Okay, I count 6. You know, Google and Facebook and LinkedIn have better diversity statistics in this meetup. We should do something about that.
That's great.
Does anybody here know any females? I don't. I'm gay, but maybe some of you people do. Oh, good point. Good point. Anybody here know who Grace Murray Hopper was? Okay, I feel better. So the CTO at Zynga has a bunch of CTOs who report to him, who have a bunch of CTOs who report to him. Any idiot can get that title. In my group, the CTO that we had 2 companies in his resume, a couple years each, both gaming companies. I qualified him to be a chief technology officer. I said, if we need more capacity, I'll just add more RAM. He said, you can't do that. The data center people aren't smart enough to deal with the fact that machines might have RAM. Now, that was actually a lie, because I saw the machine inventory. At that time, they had 18,000 servers, and they had plenty of servers with lots of memory. So he didn't even know what was going on in his own data center, and I did, which is kind of stupid. But, as I said, these algorithms are sequential scan, which means they work very well with virtual memory. I said, okay, then just increase swap space. No, we can't do that. The data center people could never deal with a machine that uses virtual memory. Okay, look, I sent you a police car, I sent you a boat, I sent you a helicopter, and you've still drowned. So I ended up having to write this code to basically implement, if you think about it, my own kind of virtual memory to roll these indexes in and out. If I sound a little peeved, it's because it was a waste of a week of my life. So we've talked about the log analysis programs. The executive is the process that sends the messages at midnight and 1 a.m. And it also keeps track of whether the analyzer processes are living or dead. It wakes up every couple seconds and checks to see if any children have died. This is what I call the Jewish parent model of programming. You wait till your children are dead. I can say that. You can't say it. I'm only saying that because I've seen him naked, so I'm pretty sure. I'm going to get letters. The log analysis programs not only sleep for random amounts of times, but they also run their main loop for a randomized number of times. Then they commit suicide, and they leave a suicide note when they do. If the executive sees that there's a suicide note left for a dead child, it just restarts it. If it sees that there's no suicide note, it sends an error message to the logs, and that automatically sends me an email. I tested that the email sending code worked, but in the year run of this program, I never got a single email. It never blew up that way. No error messages ever came out of this thing. I'm going to talk more about that in a moment or two. The reason I have the children commit suicide, and I just copied this from Apache, it's not like I invented the idea, Apache child processes do the same thing, was what if I'm not as good a programmer as my arrogance tells me I am, and the odds are, at my age, that I'm just a crank. What if I'm not very good? Then these programs might have resource leaks, and eventually they'd fall over and die. By having them commit suicide, the resource leaks get cleaned up by the operating system before they can take my program offline. So this is belt and suspenders programming. I trust nothing, including my own competence. This is how you build systems that run forever without crashing. So here's the implementation. We've talked about the first 2 items in the slide, the executive and the analyzers. There's also a web server, which is running a CGI bin script to handle the user interface side, where the queries come in. Anybody here who is not familiar with the CGI bin interface and calls themselves a web programmer, stop doing that. You're not. I actually had a guy I was working with who'd never heard of this. He said, I'm a web developer. No, you're not. Go learn about this. So I've already covered everything here except the last item on the slide. The CGI bin script is what gets the request from the user interface. When it gets a request, a query, it copies that into an inbox for each of the 16 analyzers. Each analyzer has its own unique inbox. And then it just sits in a loop and polls for results. When all 16 analyzers have produced a result, it coalesces them together, converts them to JSON, and ships them back to the requester. Pretty simple. So that's the code that's occurring on the right side of the slide here. Arrow number 1 is a request coming in from a laptop, hits the web server. The web server spins up that CGI bin process. The process with arrow number 2 creates the 16 copies into the input directories. The analyzer processes see that and process it at 4. They send their results back into the output directory. The output directory at 8 is polled by the CGI bin process. When all 16 responses have come back, it sends results back on arrow number 9. You notice I skipped over a couple of arrows. What I've just described here works fine as long as the processing time is less than a minute, and it almost always is, unless you do a full text search of all 60 days, because for that I have to scan all the files everywhere. That takes more than a minute. So I actually designed this so that when the request comes in, the CGI bin script immediately sends back a ticket number, and the web page in the browser can just pull that ticket number every 10 seconds to see if it's got a response. But management decreed that my user interface wouldn't be what these eCrime people would use, that they would use a centralized console that never worked, written by another guy, and he couldn't figure out the concept of ticket numbers and polling. So I just said, don't do full text searches across all 60 days, you're never going to get a response. I could have increased the Apache timeout, and I didn't do that. The reason I didn't was that might solve the problem today, and then tomorrow somebody puts some new box on the network that serves as a proxy server and has a 60-second timeout, and they don't know they need to make that change. So to make the system just blow up consistently, I left it as it is and did not change the defaults. One could argue that that was a stupid decision, but I don't work there anymore, so I don't care. Here's a rule of thumb for when it's time to leave the company. When you look in the lunchroom and recognize no one, when you look around the lunchroom and say, there is no one here I would like to, it's time to go. I wanted to make this thing reliable and cheap. Cheap because eCrime is not a profit center, it's a cost center. Every dime we spend is a dime taken out of our investors' pockets. And I wanted to make it reliable because of that key takeaway from the interviews that I wouldn't be allowed back on the box after turning it over to them. I didn't want to ever have to come back to this thing. So I achieved that by making it very simple. By cutting down the number of external dependencies, it really doesn't talk to most of the rest of Zynga. The internal design of the system, as you can tell from the previous slides, is not too complicated. And I made it run super fast so I wouldn't need to have multiple servers, because every time you have more than one server, things get complicated. And when you scale up by a factor of 10, all of your tools for managing servers, all of your techniques, and all of your training, and all of your traditions falls apart. So if you go from one server to 10, or 10 to 100, or 100 to 1,000, you have to redo all of your infrastructure. And what do we know about infrastructure? Put a wooden stake through its heart. And I saw this at Zynga constantly. Problems, non-stop problems with machines crashing, and people running furiously around like a disturbed anthill trying to get stuff to work. This is one of the reasons why Zynga has so many people for the number of games it produces as compared to its competitors. The ratio of people per game for Zynga is terrible compared to its competitors. The hardware and software was frozen in 2010 for the base systems. They would not allow us to use newer kernels, newer processes. The CPUs, the boxes were from 2010. That would be like Wyatt Earp showing up at the OK Corral with a knife. You know, you don't bring a knife to a gunfight. Our competitors have new machines. We didn't. Anybody here know of Leslie Lamport? Yeah, famous person. Could be a boy, could be a girl, can't really tell. An operational definition is the thing you say when you can't give a real definition. You say, well, I don't know what it is, but I'll tell you how to recognize it when you see it, like porn, for example. So here's an operational definition from Lamport of a distributed system. A distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable. And if we had time, I could give you a dozen stories about, in my career, how that's happened over and over again. So I'm not a big fan of remote systems, distributed systems. Just give me one box that I can rely on, preferably a box that I manage myself. I don't know why I put this slide here, so I'm going to skip over it. I think I just threw the slide in everywhere. I've talked about the data ingest on the left side of that slide. We have scribe set to pinch off the file at 20 megabytes. I already talked about item 2, the 16 processes competing to rename the file. The rename trick is how we achieve mutual exclusion. Rename is atomic on POSIX file systems. Not network file systems, but local file systems. Why would I use that as a way of achieving mutual exclusion? Why not use semaphores or some other obvious way of doing exclusion? All those cool things we learned about in computer science classes. And by the way, I used to teach this stuff. So I have a vague concept of what I'm talking about from an academic perspective. The reason is the file rename trick is in the file system. I'm pretty sure that's debugged. The only serious problem with Unix file systems is occasionally the people who create them murder their wives and lie about it. But aside from that, it works fine. I'm not making a judgment call, good or bad. The process that wins, the analyzer process that wins the race, updates its in-memory index, which I talked about before, moves the file to long-term storage on the same file system. So that's just a metadata operation. We're not actually copying anything. That file is still in the RAM cache, by the way, so we're actually never going to touch the disk drive after writing the file. Then I call rsync. I shell out to rsync to back up to some other development server somewhere in Zynga. And I wrote the code to copy to AWS S3 service because that mini CTO I talked about insisted we had to back up there. And I said, why? And he said, well, because S3 is simple and cheap. Okay, you're a Nimrod. At that point, if I hadn't already set the bozo bit on the guy, I would have done it right then. S3 is not simple. I know the people who work there. I trained some of the people who work there. It is very complicated to make a distributed, reliable file system. It may look easy to you, but it is not. And as for it being cheap, it is cheap, but not as cheap as backing up to a server we already own. I love Jeff Bezos. He gave $1 million to Marriage Equality in Washington. He's my guy. But he does not need Zynga's investors' money. The Zynga investors do. He has enough money, he bought the Washington Post. And you know he bought it accidentally with the one-click button. I've already talked about this, so I'll skip over it. No need to belabor that point. I talked about this, we'll skip that one too. The queries the system supports are by time box, by user ID, by conversation ID. Those are from the in-memory index. And then on disk, a query might include content, regular expression. That was a freebie I gave them. They didn't ask for it, but I thought at some point they might want it. It was easy to do. And by game ID, you might say, I only care about messages from a particular game. For example, Bankruptcy with Friends. Or, no, I'm sorry, it's called Bankruptcyville. That's the name of it. I considered putting in a plugin architecture so we could add more filters easily, and I didn't do that because the client hadn't asked for it. There was no demand for it. And making a plugin architecture is more complicated than just calling functions in your code. In my case, the functions are called by a lookup table. I was tempted to do a plugin architecture for filters to make it extensible, but I stopped. The client doesn't want that. And doing that's just going to make the code more complicated, less reliable, more costly. Don't want to do that. Deliver what the client asks for. Don't go beyond it except for maybe one or two little freebies. I talked about increasing capacity because the mini CTO thought we were going to have a popular game coming out. Turned out it was a flop. That's funny. I guess you don't own. You probably own stock in Disney or EA. I still have my. I ran out of time today because I was at a job interview this afternoon. I was going to start this with a slide of Zynga's stock price going down. Ran out of time. Maybe next time. So we could increase the capacity by smartening the logic. I actually did that a couple times during development. I changed the structure of the index that I showed you to the form that was there, measuring the memory efficiency of various different ways of representing the data. We could add RAM, we could add swap. We could just go to a bigger machine. Instead of 8 physical cores and 72 gigabytes of RAM, it turns out Zynga had plenty of bigger machines, but I didn't know that. Or we could add servers. We could shard by game, we could shard by user and conversation ID. But I don't want to add servers if I don't have to. And in fact, the system is built so you never have to. At idle, it's taking 3 gigabytes of RAM on a 72 gigabyte machine. It is very unlikely Zynga will have a game so popular that it's ever going to run out of 72 gig. This slide I put in here because Mr. Bruby in 7th grade English said, I don't care if you forget everything else, always remember this rule, so I did. He went to jail later for other reasons. All of my stories end that way. Bankruptcy, jail, death, I don't know. Let's see, autonomous operation. I don't want to ever get a phone call from the network operations center about my machine. I don't want it to ever send me email about errors. And for heaven's sake, I never want to get a phone call or email from my client that they've found an error before I have. That is totally embarrassing and stupid. So I built a system to maintain itself. It takes care of itself, as I said. There's more I could have done to make it autonomous, but I didn't have to because this was not a terribly complicated problem. There are some other programs I've written at Disney, at a previous company, which had a lot more work involved in making them function autonomously. Basically, I don't want to get 3 a.m. phone calls. I don't want my successor to get 3 a.m. phone calls. Because when you get those phone calls, what do you want to do? You want to go back to bed. So you make the shortest possible solution. You do cowboy coding, you hack things, and in the morning you forget that you did it, and your system starts to degrade pretty badly. Or you put in a patch that makes things worse instead of better and just results in cascading failures. So I really want to avoid those kinds of problems. One of the ways I improved the reliability of the system was by not touching the code elsewhere in Zynga. Now you might get from this the notion that I'm an arrogant bastard, and that's probably true. And I don't know if I'm good enough to be an arrogant bastard. I do know that I disagree with a lot of stuff that my younger peers are talking about, and at my age that probably means I'm a crackpot. So a few months ago I became a freshman at the College of San Mateo, and I'm doing the 4-year computer science curriculum all over again. So when I finish, it's going to take me about 10 years, I'm going to know more than any of you people. I'll know the newest stuff. At Zynga, most of the machines run on a virtual platform, 1-to-1 ratio of physical to virtual. So they're not using it to cram more processes in a single box. They're just using it so they can manage things through a hypervisor. I avoided that. I said, the data rate you've told me we'll have to support is so high that the overhead of the virtualization layer on networking would kill performance. So we need to run on bare metal to get the network performance. They bought it. Fine. No hypervisor. No complicated IPC stuff. Stick with things that are simple and work. No use of Java or any other cross-language bindings, pure Python. No connections to the outside world until I added in those backup capabilities, calling rsync and S3 command. No connections to the monitoring utilities, just send me an email for errors. Why? Because email usually works. The rest of the stuff, I didn't write it, I don't trust it. We actually didn't have any problems with PagerDuty. Nagios, on the other hand, caused us problems occasionally. It's pretty complicated to use. We had a couple of experts, and if they weren't available, things would break. And because it's just one server, I don't need Splunk. I can just look at my log files whenever I want to. Splunk is great, I love Splunk. But Zynga had a full-time staff of people to keep Splunk happy, which tells me it's complicated and error-prone. I don't like that. And in fact, when conversations got moved to a different data center as part of Zynga's collapsing 5 data centers down to 1, all of the Splunk queries that my predecessor had built for the conversations plugin broke because some Splunk index died and no one could ever figure it out. So I love Splunk, but there was no need for it here. Keep it simple. I also wanted the system to be reliable, to be secure, so that the eCrime people could testify in court. So I made sure the system was as small as possible, with no database services or anything else that people could get at. Keep it small, keep it simple. I gave a different version of this talk with a lot more internal detail that I would feel uncomfortable sharing with people here when I was still at Zynga. My last week, they didn't know I was quitting. They just knew I was going on vacation, from which I was not returning. I gave this talk. And if you think I sound a little unhappy now, you should have heard the talk when I gave it there. And so here are the questions that people asked afterwards, the alpha version of this presentation. How do you detect if your server failed? Well, I could, if I wanted, hook into Nagios. That would tell me. Or I could implement what's called the Robin Hook Friar Tuck approach, which is you have 2 servers monitoring each other, and if one fails, it tells you about it. So Robin Hood will say, Friar Tuck is under attack, or vice versa. You know what to do. In fact, what I did was, when the system was new, I would check it every day, and then as the system showed that it was stable, I cut back to testing it to checking in every week or 2. I would check the log files, make sure that everything was fine, there were no errors that I hadn't been notified about, check the disk capacity, check CPU. At idle, under normal operations, the CPU load is, the load average is 0.05. So this box is not doing much. Another question, why not use Elasticsearch? Well, because they take more servers. It's more expensive. More stuff to break. We didn't have a lot of experience with Elasticsearch, so now we'd have to train the ops team on what to do about it. It's complexity, complexity, complexity. Why do that? I already talked about Amazon S3 being simple and enterprise scale. But the last sentence in the answer here I think is worth mentioning. Just because something is shiny and new doesn't mean we should jump on it. I went through this in a company I was at very briefly, which is why I'm now looking for another job, where one of the engineers wanted to use CBOR instead of JSON. I said, oh, okay, fine, whatever. Terrible decision. It cost us a week because it turns out CBOR is unreliable, corrupts memory, and you don't find out about it until 10 or 20 minutes later when Python tries to do a malloc and blows up. It took us a week to track that down. We stick with things that work because we are not, assuming you're a professional programmer, we are not in the business of trying out shiny new toys. We're in the business of delivering solutions to customers for which they are willing to part with money. Kevin O'Leary on Shark Tank, it's about money. I like money. If you want to play with shiny new toys, get a job in research. Go back to college. If you want to deliver stuff to customers that is reliable and stable and cheap to operate, hey, hi, Bill, then use the stuff that works. And when it comes to backups, Bank of America and Exxon and General Motors have got that problem solved pretty well over the last 50 years. And they weren't doing it using S3. They were doing it using tape, then using nearline disk, using optical drives, and so on. And finally, the last of the questions was, instead of this custom alerting and monitoring software, which consists of calling the Python logging routines, not terribly custom, why didn't you use Nagios and PagerDuty and so on? And my answer to that is a little tongue-in-cheek, because by this point I was tired of stupid questions. It was, look, if you need all of those tools to manage your massive cluster, why don't you ask yourself if you really need a massive cluster? I think I'm heading, yeah, that's the end of this presentation. One last point before I shut up. This is the Galaxy Note 3. It's about a year old. It's obsolete. This phone has more compute power than all of the mainframes on the east coast of the United States when I was in college. If you have a problem so complicated it cannot be solved by my telephone, then you probably work at Google. Or Apple or Facebook, but it's all the same company now anyway. We just refer to it by the abbreviation NSA. It's been nice knowing you. Please visit me at Gitmo. As an industry, we're doing a couple of stupid things. We are throwing servers at problems instead of throwing engineers at them. Yeah, engineers are expensive, but running a server farm with 10,000 servers is even more expensive. Not only is it expensive, but it also incurs a lot of costs in terms of reliability and employee burnout. You can get a massive amount of compute power in a server. Not my phone, but a real server. At the top of the line, IBM, I think it's now Lenovo, I think they sold that business last week, offers a server, the 3960, I think it is, 3950, 120 cores, they'll be bumped up to 150 in a couple months, 12 terabytes of RAM, 25 terabytes of flash, 4 10 gigabit NICs, more if you need them. And by the way, it has a bunch of slots where you can plug in NVIDIA accelerator cards or Intel PHY cards. That's a lot of compute power. And it's all available at the drop of a hat. Call your IBM vendor and they'll ship it over. So that's about it for me. Thank you for your time. If there are any questions, let's take them and then we'll break for more pizza. Thank you. Questions, comments, concerns, insults? Bill. Oh, I think I'm supposed to get you a microphone or something. All right, go ahead. Mm-hmm. Sure, I don't remember the exact numbers anymore. It's been a while. But because I keep all the raw data files, since we're going to need them to do the search later, I took a look at the total number of messages in a corpus after the system had been running for a few days. And I compared that to the size of memory. And I also took a look at memory when the processes were brand new before they built any indexes. So by subtracting the one number from the other, I could get the cost of the index. And I did a lot of this early on in tweaking to get that data structure to be the smallest possible size. And then I could figure out, by dividing that by the number of messages in the raw data store, how much a message was costing me on the average. Now that number was slightly skewed because the earlier game that was in the system, the earlier big game, was a game that only put one-word messages in it. It was some game where I think you have to draw a word and somebody else guesses the word you're drawing or something like that. I never played any of these games, I don't really care. So that skewed it to have smaller messages. But I was able to make a prediction about the maximum capacity. Usually I allow like a factor of 2. I'm a little paranoid, but not super paranoid. And I did, yeah. Oh, I'm sorry. So Bill's question was how much slack. I interpreted that as how much slack in my ability to make estimates. You're saying how much capacity for extra messages. So at idle, with one popular game and a bunch of not very popular games, the system takes 3 gigabytes of RAM on a 72 gigabyte box. I figure that gives me enough slack capacity that a game would have to be awfully big to run out of it. If it does, then we could either go back and make the algorithms more efficient, which I'd already done. There were a couple of things I could do to make it even more efficient. For example, instead of rolling the indexes out every day, I could roll them out every hour. I would shrink it down at the cost of making queries a little slower. Or, if it's a problem, add more RAM to the box. Turn on virtual memory. Those are cheap solutions. Or I could shard it, but I want to avoid that. What happened in the late 90s was Intel and Sun started to put out this nonsense about how horizontal scaling was the way to get high performance everywhere. Why? Because they didn't have fast boxes and they wanted to sell you a lot more boxes. Horizontal scalability is one way to achieve high performance. Unfortunately, in our industry now, it has become the only way to get high performance. I maintain it should be the last way to get high performance. First, if you need higher performance, look at your algorithms and fix the problems. And unfortunately, some of the programmers I've been working with lately who are fresh out of college have never learned how to do performance tuning. There are very simple tools like strace and ltrace you can use to find out what your program is doing and then fix it so it doesn't suck. Once you've got as much speed as you can out of the algorithm, then look if you can put a bigger box in. Bigger box is a pretty cheap way to solve the problem. Makes the problem go away, you can work on something else. Only after all of those other techniques have failed should you worry about horizontal scalability. And here's the reason why. To solve some problem, you have a whole universe of algorithms you could pick from. But in that universe, only a small subset of them are compatible with horizontal scalability. Why would you want to reduce the universe of algorithms you can choose from to that little corner? You want to be able to pick the best algorithm, not the one that's capable of running on a Hadoop cluster. So that's why I say horizontal scalability is a solution, but it should be the last one you try, not the first. Does that answer your question? Thank you, Bill. More questions? Fewer questions? Anybody want to take a question back? Yes, sir.
People chatting on Zynga really know that every conversation they're having is recorded.
I'm sure the question was, do the people who use Zynga games, our valued players, know that everything they do is being recorded? I am sure it is fully disclosed in the terms and conditions of using the service. Subsection 26, paragraph 4. Who knows? At this point, I would hope that people are aware that everything they do is being recorded. In fact, the job interview I did today, the guy was telling me that they are keystroke logging every single thing that their employees do, every keystroke. And they're not doing it for security, they're doing it because it's all going in a data store so they can measure how many keystrokes to process an order so they can do performance optimization. They want to go back and cut down the amount of expense they have for, I think, dealing with faxes or something. And he said it's incredibly eye-opening looking at that level of detail. It's also very time-consuming. So the answer to your question is, I don't know, outside my area of expertise. Yes, sir. The question is, would I recommend Zynga stocks? Hold on a second. I actually have an answer for that, courtesy of my friends Manny and Peter. Let's see. Zynga is a great, great company with a bright, bright future. I signed my name to that as part of the severance agreement. I'm pretty sure. It's in there somewhere. I still have my Zynga stock, but that's because it came to me as part of the employment, so it's just free money. And maybe it'll be worth something if they get acquired, maybe it won't. I have no idea. If I knew about stocks, this shirt would not be 14 years old. And I'd be wearing shoes instead of boots. Any more questions? What? What? Yeah, I'm supposed to take my style cues from you.
Not the boots.
Not the boots, okay. All right, if that's no more questions, thank you all. Let's get some more pizza.